Hi guys, we're ready to go with Chapter 3, Section 4. We're going to solve equations with variables on both sides. As you know from class today, I'm losing my voice. Definitely got a cold, so bear with me. I got to get this video done. Okay, so Section 3, 4, we're going to solve equations. This time, we're going to have variables on both sides, and by that I mean both sides of the equal sign. The goals here are to be able to deal with those variables on both sides, solve for the unknown, but also two new topics are coming into play here in this section. So far, we've only seen equations that do have a solution. In this section, we're going to see a couple of other things happen. First one is called an identity, and that's where the equation actually has an infinite number of solutions. We're going to be able to identify that and show how that's possible. And going back to number 2 here, we're going to look at an equation that does not have a solution at all, which is certainly possible. Okay, so let us start here. First thing, how do we deal with variables on both sides? We want to collect. By that I mean get them all together. We want to collect variable terms on one side, and we want to get pure numbers or constants on the other. So we want to get all the constants together on one side of the equal sign, all the variable terms on the other side. Now this could look a little bit different. You could have the constants over here and the variables over here, depending on what's convenient to you. But the idea is you want to get them separate, one side and the other. Okay. Let's take a look at two examples where we have variables on both sides. Here we've got 5x and minus 2x over here. They're on either side of this equal sign, and we've got to get those together. We want to collect them together. So let's start with that minus 2x. As we've been doing with the pure constants, if this is a negative or subtract 2x, in order to undo subtraction, we would use addition. Now when I do that on the other side of the equal sign, I'm going to put that right under its like term. So 5x plus 2x is 7x. We haven't done anything here with this subtract 5. Okay, so just bring that down. We haven't dealt with that yet. Bring the 9 down. We haven't touched that yet. And just like negative 2 plus 2 would be 0, negative 2x plus 2x would also reduce to 0. All right, now we're here with an equation that looks like something we've been dealing with all along. We've got x here being multiplied by 7, and we're subtracting 5. We're going to undo that subtraction of 5. Remember, we work from the bottom up. So we're going to undo that subtraction with addition. And we've got 7x. Our opposites reduce to 0. And 9 plus 5 is 14. And finally, we're going to undo that multiplication with division. And 7 divided by 7 is 1. X equals 2. Okay, we should certainly always check our answer. We do that by substituting what we think the answer is. So we swap out the x, we put in 2. I like to show that multiplication with parentheses, as you know. And we're going to do multiplication first. 9, and we have to do multiplication over here first. 5 equals 5, and that checks out. Once we know that we get a true statement down here, true equality, we can be satisfied that x does equal 2, and we've checked it out. Okay, let's try example number 2. We've got 3w and w here. We notice we've got another w term over here. So we need to get all of those w terms together. As we've done before, definitely try to combine any like terms on one side of the equal sign first. As you know, this is a 1w here. So 3w plus 1w is 4w. So right now I'm only combining like terms on one side, and then just rewriting everything else. Now I want to get that negative 2w here, we can see it right here on this side. I want to get that over to the left with the 4w. If that's a negative 2w, the inverse operation is a plus 2w. And when I do this, on the other side of the equal sign, I'm going to put it right under its like terms. 4w plus 2w is 6w, and the plus 4 just comes down. We haven't dealt with that yet. Opposites reduce to 0 when we sum them, and the negative 20 just comes down. Now, as I had said earlier up here, we want to collect variable terms on one side and constants on the other. Okay, so we want to get that plus 4 out of there, and we want to get that over with the negative 20. So we're going to get that over here. We've got 6w coming down. We've got the opposites reducing to 0. Negative 20 minus 4, negative 24. And we're going to finally divide out that 6. And, of course, that reduces to 1. And we end up with a negative 4. Now, I'm going to ask you to check to see if negative 4 is the correct answer. So for your homework, I want you to check that answer and make sure we get true equality. Okay, now let's take a look at examples of two equations where there actually is no solution at all. We're not going to be able to solve for the unknown here. So how does it happen? Well, look at this first example in number 3. We want to get the variable terms on one side and the constants on the other. So here I have a plus 8a. There is no negative sign in front of there, so it's automatically assumed to be positive. If I want to do the inverse operation and bring that over to the other side of the equal sign, what I get is opposites reducing out to 0. 8a minus 8a is 0. Over here, 8a minus 8a is 0. They're both 0. So we have down here 6 plus 0 equals 0 minus 3. 6 plus 0, of course, is 6, and 0 minus 3 is negative 3. Now what's going on here? 6 can't possibly equal negative 3. We ended up here with our variable terms disappearing. They've both reduced out to 0. We have no variable left, and yet we have a false statement. If this happens, if your variable terms go away and you end up with a false statement, the answer is no solution. In this case, our variable is a, so a is no solution. There's no number that we can substitute in for a and get a true statement. All right, let's try example 4. First off, let us get rid of these parentheses with the distributive property. So we've got 3x plus 3 times x is another 3x, and 3 times 2 is 6. Over here we have 6x minus 3. It's always a good idea to combine any like terms on one side of the equal sign first. So 3x plus 3x is 6x plus 6. And over here we have 6x minus 3. Now, over here to the right, this is automatically assumed here. I'm talking about this term here is automatically assumed to be positive. So we're going to use inverse operations to move it over to the left. And 6x minus 6x reduces to 0. Same thing over here. So again, we end up with 6 equals negative 3. Not possible. This is a false statement. And the answer here is x equals no solution. There is no value of x we can solve for here. Okay, so these are two examples where there's no answer possible. Let's take a look at a situation that is possible where we have actually an infinite number of solutions. We call that all real numbers. When we solve a situation like this, we say that the variable equals all real numbers. It has an infinite number of solutions. All right, so let's take a look at example 5. First, let's get rid of these parentheses with the distributive property. 2 times 3x is 6x. 2 times 5 is 10, so we're going to subtract 10 here, equals 6x minus 10. What do you know? We've got exactly the same terms on the left and the right. If I subtract 6x from both sides, I would end up with negative 10 equals negative 10. Let's try that out. Subtract the 6x from both sides. Cancel, cancel. We end up with negative 10 equals negative 10. Now this is a true statement. Our variable term disappeared, just like the previous example, but now we don't have a false statement. We have a true statement. So in fact, and we could try it out in class, there's no number that we can substitute in for x and not get a true statement. We could choose 1, 2, negative 1, negative 2, 100, negative 100. In fact, x equals all real numbers. Every single number that we can plug in or substitute will give us. Try example 6, another example. Remember, try to get rid of parentheses first with the distributive property. So I'm going to remind myself of that here. Negative 5x, can't deal with that yet. Think of this here, the subtract 2, is really a negative 2. So negative 2 times x is negative 2x. Negative 2 times a negative 4 is positive 8. And I'm just going to rewrite those. Again, try to collect, or combine I should say, any like terms on either side of the equal sign if possible. So negative 5x minus 2x is negative 7x plus 8 equals negative 7x over here plus 8. What do you know? Whenever you get exactly the same terms, negative 7x plus 8, negative 7x plus 8, you know that when you start to do your inverse operations here, that variable term is going to drop off. They're going to reduce out to 0. And here you're just going to end up with 8 equals 8, which is a true statement. So we have a true statement. Our variable terms fell off the planet here. So we know that x equals all real numbers. Infinite number of solutions. Okay, as part of your homework here that's going to be due on Tuesday, I want you to do these 4 problems. I want you to check the previous answer on the first page that I asked you to, and then I want you to do these 4 problems on your own. They're a mix of a single solution, no solution, or all real numbers, an infinite solution set. So I want you to see out of this mix of 4 problems what you get. All right, I'm going to give you one hint though. Remember here, I know you don't like fractions. Sometimes rather than using the distributive property as we've been doing in class, just get rid of that fraction by multiplying everything by the denominator. Okay, then you can go ahead and cancel and then do the distributive property. All right, thanks for listening. Take care.